This video we're going to learn about hydrates. Now, as hydrate implies, that means that it's a compound that has water attached to it. So for example, this would be copper 2 chloride dihydrate. And what I want you to notice here is this dot means that each CuCl2 formula unit has two waters attached to it. So that's what we use to represent, and you'll see that dot. And we use the prefixes that we used back in covalent compounds to indicate the number of waters, and we'll do some practice with that as well. So the steps are going to look very familiar. They're going to look just like our empirical formula steps. We're going to read, circle, underline. We're going to convert to moles. We're going to find our mole ratio by dividing by the smallest. And then we're going to use that whole number ratio as the coefficient for your water. So here's the example problem that you have. Find the formula of a hydrate. Alright, so that's what we're trying to find. That contains 0.391 grams of lithium hexafluorosilicate and 0.0903 grams of water. So we have to do 2 mole conversions. Okay, so we need to convert 2 moles. So I need to do grams to moles, which means I'm going to need the molar mass. So 1 mole of lithium hexafluorosilicate has a mass of 156 grams. Now I did that by doing the stack it, okay, multiplying and then adding them up, and that's how I got that number, that 156. Same thing for water. 1 mole is 18 grams. So now I'm going to do my 2 mole conversions. So 0.391 grams, and make sure you label everything so you know what we're doing. Alright, so I need grams on the bottom, so 156 grams to 1 mole. When I do the math, put that over 1. Okay, see my grams cancel, so I'm left with moles. So my answer here is going to be 0.0025 moles. And we do want to carry it out that far, okay? So that's my lithium hexafluorosilicate. Now I'm going to do the same thing for water. So 0.0903 grams of water. Alright, we want grams on the bottom here, so 18 grams, 1 mole on the top. Then we do this math, we get a number of 0.0050 moles of water. So now we need to look at our ratio. Alright, so we have 0.0025 to 0.0050. 0.0025 is the smallest, so we want to divide by the smallest. That gives me a 1 to 2 ratio. So that means my formula is lithium hexafluorosilicate, don't forget the dot, to H2O. So the name would be lithium hexafluorosilicate dihydrate. Let's look at another example. Now in this case we have those percents. So again, we're finding the formula of a hydrate that has 76.1% calcium sulfite and 23.1% water. So remember the percents, all we have to do is assume we have 100 grams and we can make those percents be grams. Alright, so we do need to do 2 mole conversions, so we're going to do grams to mole. So for calcium sulfate, I know that 1 mole is equal to 120 grams. Alright, that's my calcium sulfate. And I know for water is 18 grams per mole. So now I'm going to do my 2 mole conversions. So 76.9 grams of calcium sulfite. We want grams on the bottom, so 120 grams to 1 mole. So my answer here is 0.641 moles. I'm going to do the same thing for my water. 23.1 grams of water. Alright, so we want grams on the bottom, so 18 grams, 1 mole on the top. We do this math and we get 1.28 moles. Okay, so we look at our ratio, 0.641 to 1.28. 0.641 is my smallest, so I'm going to divide by the smallest and I get a ratio of 1 to 2. And it just worked out that both of those problems were 1 to 2. So my formula is CaSO3, don't forget the dot, 2H2O. So calcium sulfite dihydrate. Let's look at one more example. Now this example was not on your sheet that I gave you, but it's one that you may see. Now this one we're going to have to really pay attention to. Okay, so we have 15.67 grams sample of the hydrate of magnesium carbonate without decomposing the carbonate to drive off the water. The mass was reduced to 7.58 grams. What is the formula for the hydrate? So what we need to see here is that when you burn a hydrate, all right, when it's heated, you drive the water off of the hydrate and you're just left with the anhydrate. Okay, so what we have is the hydrate is going to be equal to the anhydrate plus the water. Okay, so that's what happens in our formula. So in this case, our hydrate is magnesium carbonate, so that's MgCO3 plus 2 minus 2, we're good. Now we're looking for X here. We don't know how much water we have. Alright, so the anhydrate is the magnesium carbonate, and then we have X amount of water. So our information here tells us that we have 15.67 gram sample of the hydrate. So that means that this hydrate was 15.67 grams. Then it tells us that the mass was reduced to 7.58 grams. So that's the mass of the anhydrate. Okay, we can't really measure the mass of water coming off, so we can measure the mass of the anhydrate that is left here. Okay, so then what we want to do is subtract to find the mass of water. And when we subtract, we get a mass of 8.09 grams of water. So 15.67 minus 7.58 is our mass of water. So now we can do our problem. We can convert to moles and we can get our ratio. So I'm going to do that for you really quickly. So we do 7.58 grams, and that's our MgCO3. Alright, now I've already calculated the molar mass, so that molar mass is 84.31 grams. That gives us 0.0899 moles. I'm going to scroll up just a tad. Alright, then we used the mass of water that we got when we subtracted. Okay, and we convert to moles, 18 grams. So that is 0.449 moles. So now we look at our ratio and we get 0.0899 to 0.449. So 0.0899 is the smaller. 899, can't write. So the ratio is 1 to 5. So our formula is MgCO3.5H2O. So magnesium carbonate pentahydrate.